Um, I did a presentation. I did a program that is supposed to help manage wine cellars. So you can add wines, remove wines, and get recommendations for a certain type of wine you want to drink based on attributes that you put in. So for example, if you want a really old wine from France, you can say that and it'll print out all of the wines currently in your wine cellar database that match those attributes. The idea behind this sparked from the fact that my dad is a wine collector and I'm really interested in wines, and he has a whole system set up, but I don't think that's what the majority of people do. It's really hard to keep track of all the wines in your wine cellar, especially when you have to take into consideration all of the varying attributes that they all have. And it's also just hard to sort your wine cellar, so you might put them by year, for example, but then if you're looking for a certain country, then the physical wine cellar won't be sorted in the right way. So an extension of this program could be finding the placement of each wine within the wine cellar. So this is basically what my program looks like. Well, a visual representation of it. It's a lot easier to understand if I give you the graph, because explaining it out loud has proved to be very complicated. So I basically have the overall program called Corkit is represented by the bigger rectangle up at the top. It contains the route to a try that contains all of the names of the wines in the database. And then it also contains a graph with routes to the tries for all of the other 8 attributes, which include the varietal, which is the grape used in the wine, the country, the vintage, which is the year, the color, the rating, the winery, the worth, and the number of bottles held in the wine cellar. The use of having them split and having name on its own is so that if you're searching for a particular wine, you don't have to go through all 9 tries to figure out if you have it. You just need to search the name try, and if it's there, it'll show up, and you can then go and search for it in the other tries. What's also useful about this is that I don't have to have a bunch of different copies of each wine bottle. I just have one copy of it, and rather than having an end of string bool at the end of each string in the try, I have a pointer to a vector that contains pointers to wine bottles. So I used a number of algorithms. Lexicographic sorting is basically it's basically pre-order traversal, which we've done in lab. The only difference, which was, and complication, is that rather than having 2 children, so you go left, root, right, is that you have 26 children for each letter of the alphabet. And you also have to take into account that if you're trying to print words, you have to print words that are contained within words. So if you have cat, which isn't a line, but if you have cat and then you have caterpillar, you have to make sure that you print both cat and caterpillar. So it's not as simple as traversing through a tree where you just use each node once, or, well, we did in lab at least. Then merge sort I implemented from the homework 5. The only difference being I was sorting through based on, rather than sorting the list of numbers, it was sorting a list of wine nodes, and it was sorting them by a specific integer within the wine node. For insertion, so if I go back to this one to explain, When I inserted a wine, so I first took in all of the attributes by asking the client to give me each of the 9 attributes of the wine, and then I create a wine node, or rather a pointer to a wine node, and then I search for it in the name try if it already exists. So if we're trying to add X photo, we search for it and it is there, so all we do is go into the array and go into the wine and say increment the number of bottles of this particular wine by however many you're adding. If it's not there, and then after that step is done, you've finished adding it because it's already in the wine database. And by updating this wine bottle, you've updated you've updated the wine bottle that all of the other tries are pointing to, so you're basically finished. Otherwise, you have to add an entire new string and create a new vector that points to a new wine bottle, but you have to do that for all 9 strings, so that takes longer. Removing is basically the same thing, except that rather than adding a string, you have to remove a string. You only remove the string in the case that you're removing the last wine bottle of the kind. Otherwise, you just decrement it. And then, so for recommendations, I asked the client to give me one or several attributes of a wine that he or she desired. And for each attribute, the program goes to the correct attribute try, and if it finds the correct string within that try, it'll return the vector, and it'll increment. There's a desirability counter within each of the wine nodes, and it increments it and adds it to a vector. And it does that repeatedly for each attribute that the client asks for. If the wine is already in the recommendation vector, then all you have to do is increment the desirability of it again, but you don't want to copy another version of it into the wine vector, into the recommendation vector, otherwise you'll have 2, so it won't be useful for sorting purposes at the end. Once you've added all of them, you just sort the recommendation vector using merge sort based on desirability, and the top ones come out as front. So my biggest challenges were putting everything together. This is by far the biggest program I've ever written, and it was really complicated to keep track of everything while I was writing it, especially because I was starting from the bottom and going up. But sometimes when you get to the top, you realize, whoops, I forgot I had to implement this for like a function all the way at the end of the program. So that was difficult. A lot of pointers, mainly just putting everything together was really difficult. So the demo. I've already added a bunch of wines to the database to make this more interesting. So these are all of the wines that are currently in the database by attribute. So these are all the names, the wineries, etc. We're going to add a wine. So it asks you if you want to add, remove, get a recommendation, or print information about the database. So we want to add a wine, and we're going to add this wine. So you have to enter each attribute on its own, because I figured if you asked the client to add 9 attributes, they would definitely get them in the wrong order and mess up the program. So this is simple. So if we then go and print it again, we see that we have Cheval Blanc, which wasn't there the first time, all the way up here. So we've managed to add it. If we then decide to remove a wine, for example, we again have to enter all the attributes. So a further thing I could improve about the project is having it remove all wines that have a certain attribute. That would make it simpler. So I have one issue with my remove is that it removes everything correctly. So some of the varietals, for example, you'll still see the same number of them. That's because other wines have the same varietal, so it won't take away that string from the try. The only issue is that it doesn't remove the name of the wine, but it removes everything else. So that's to take into account. And then if you want to get a recommendation, does anyone have any favorite wines?
Pinot Noir.
So that would be anything else, or just that?
Carlo Rossi.
Pardon?
Carlo Rossi.
I don't have that in my database. I mean, we can, if you tell me how to type it, I can type it, and the program will tell you we don't have it.
It's terrible, you don't want.
What other attributes might we choose from?
So there's color, country, winery, name of the wine, number of bottles, worth.
Okay. So we can't do it based on flavor profiles.
Not yet. You can add attributes
Bitter
there.
pairings or something.
So if we just do Pinot Noir, it's going to say, well, the only one that we have matched is La Tèche, which is a really good wine, so would recommend. It's super expensive and out of my budget. If we ask for several attributes, we can do that too. So say if we want French wine, and we also want white wine, it will give us all of the French white wines in the database and tell you how many of the desired attributes it matched. So,
Maybe we can search by vintage too, I see.
yes. Yes. So that's all it does. But it's pretty cool, and it's going to get better. I don't know how to get my slideshow back up. So, all right, here we go. So what I learned is that thinking ahead is really important, especially because, as the other two presenters mentioned, it's really different doing a project when you have to come up with everything from scratch, from beginning to end. And you don't really have that much guidance because people don't know what you're doing until you try to explain it to them in vain. It also, because of this, taught me how to talk about what my code does or what it's supposed to do, what I'm trying to do, really in a completely different way, because usually TAs come and they know exactly what you're doing and they know what the problem is before you tell them. And it's just easy, whereas now you really have to explain what the problem is, what you're trying to do, what's going wrong, and you have to find the issue in a different way for yourself, but also to help the TA because they won't know otherwise. For myself, as I said, it's the largest program I've ever written. I'm sure it's small relative to the programs out there, but it was a big step for me, so I'm very glad and proud about that. And also drafting, which goes hand in hand with thinking ahead. I think I wrote about between 5 and 7 graphs for how I was going to do this. And the one in my specification actually is completely different from the one that I just showed you on the board. So if I had just tried to implement it right away, I would have had 7 different drafts that probably would not have worked by now. So it's super useful to draw things out and think about it before you start coding. So yeah, thank you so much for making this possible. Does anyone have any questions? Yes.
So you mentioned the database storing the wines. Is that like, if you add something and then want to use this program later, would you be able to like keep adding and removing and like keeping track of your wine at different times, or does it all have to be in one running of a program?
So at the moment, I guess if you wanted to use this, you would have to have a computer in your wine cellar constantly running this program, because if you quit, everything is lost and you have to type it out again. So not too useful, but that could be changed. Yep.
Do you know what the algorithmic runtime for like searching for stuff and like deleting stuff is?
To search for it, if you searching, well, if you're inserting it, it's just going to be the length of this. Okay, well, that's complicated. So if you're inserting it and it is already in the database and you're just incrementing the number of bottles you have, then it's just going to be the number of characters in the string of the name of the wine. If you have to insert it completely, then it would probably have a runtime of the number of characters in the string for every single attribute, because it has to go into each attribute try. And then the vector wouldn't take any extra time because that's constant. Searching would also, it depends how many tries you search in, but it would generally be the number of characters in the strings you're searching for. Plus, for recommendations, you would have to take into account the merge sort, which is n log n, and then printing out would also probably take time. Okay, cool, thank you.
All right, thank all of you for coming. If you have more questions, I'm sure you can find the presenters, but otherwise, I think we're all set.
Thanks everybody for coming.
Have a good one.
Thank you for presenting.